Introduction to Data Science and Python. Introduction to Data Science and Python topics covered in this notebook. Introduction to Data Science. What is data? Types of data: structured, semi-structured and unstructured. What is science? What is data science? Core components of data science. Second is data science as a discipline, literature analogy, learning roadmap through analogy, from alphabets to advanced applications. The data science ecosystem, key role of Python, key features of Python, important Python libraries for data science. Fourth is understanding Jupyter Notebook.py versus .ipynb, types of cells, edit modes versus command mode, important shortcuts. Fifth is Python syntax rules, case sensitivity, indentation, comments, single line comment, multi-line comment, variables, identifiers and keywords. What is variable? Identifier versus variable versus keyword. Naming rules, INC rules. Naming conventions and namespace concept. Now let's begin. What is data? In context of data science, data refers to any information that can be processed by a machine. It may be or may not be immediately meaningful to humans, but if a system can interpret and process it, it qualifies as data. Examples: numbers, example sales figures, temperature readings, text, that is customer reviews, images, pixel views, audio signals, logs and system records. Types of data. Data can broadly be classified into structured data, organized in tabular format, row and columns. Example, Excel sheet and SQL database. Semi-structured data does not follow strict tabular format, has some organizational properties, example JSON, XML files. Unstructured data, no predefined structure, example images, videos, raw text document. Important note: just because data is machine readable does not mean it is clean, it is meaningful, it is ready for modeling. Data often requires cleaning, transformation, processing, feature engineering. This entire discipline of preparing and analyzing data is what leads us to data science. What is science? Science is a methodological and rule-based study of a discipline. Key characteristics of a scientific study: it follows defined rules and processes. It is reproducible. It is fact-based. It produces consistent results when repeated under the same conditions. In simple words, if two people follow the same method on the same data, they should reach the same conclusion. What is data science? Data science is a scientific study of data. It combines multiple disciplines: mathematics, calculus, arithmetic, statistics, probability, hypothesis testing, descriptive statistics, computer science, programming, data structures, business understanding, visualization, and storytelling. A data scientist does not just analyze data, they extract insights, explain patterns, and support decision making. Core components of data science. Data science is a intersection of mathematics, optimization, calculations, linear algebra, optimization, calculation, and linear algebra, that is part of mathematics. Statistics, probability, inference, data summarization, programming, writing code, automating tasks, building models. Business knowledge, understanding context, interpreting result meaningfully. Communication, visualization, storytelling, presenting insights. If data science were like studying literature. Before we move into tools and environments, let us understand what we are about to study. Imagine we were not here to learn data science. Imagine we were here to study literature. How would you how would that journey look? Studying literature. If we study literature, we would typically go through alphabets, words, sentences, grammar, knowledge and stories, poems, epics and dramas, how to like famous authors and become one, Shakespeare's, Kipling, etc. How to write like famous authors and become one, Shakespeare's, Kipling, etc. Language system, English, Latin, etc. Notebook to write and practice. Now let us draw a parallel. What if data science is just another language? What if we are here to learn how to read and write with data? Parallel between literature and data science. Literature, data science, alphabets, data structures, list, tuple, dictionary, set, words, built-in functions, modules and packages, sentences, small programs and functions, grammar, Python syntax. Short stories, data exploration on simple data sets, poems, ballads, descriptive statistics and visualization, epics, dramas, modeling, hypothesis testing, applications, Shakespeare's, Kipling, data scientist, ML engineer, analyst, English, Latin, Python, notebook, Jupyter notebook, writing desk, IDE versus code, Spider and RStudio. What does this analogy teach us? Just like we cannot start reading or become like Shakespeare without learning alphabets, we cannot build machine learning models without understanding Python syntax, knowing data structure, learning functions, practicing small programs, exploring simple datasets first. Roadmap of our journey. So our learning path will look like: learn the language Python, learn the grammar, syntax rules, learn its alphabets, data structure, learn to form sentences, programs and logics, explore small stories, data exploration, then move to larger works, analytics, modeling and application. Let's repeat. Learn the language, that is Python, learn its grammar, syntax rules, learn its alphabets, data structure, learn to form sentences, program and logic, and explore small stories, data exploration, then move to a larger work, that is analytics, modeling and application. Data is not a magic. Data science is not a magic. It's structured learning, just like literature. The data science ecosystem. To study literature, we need a language, English, Latin, a notebook, a pen, a classroom. Similarly, to study data science, we need a programming language, an execution environment, supporting tools, a package management system. The programming language Python. In our journey, the language we will use is Python. Why Python? Simple and readable context syntax. Simple and readable syntax, large community support, rich ecosystem of libraries, widely used in data science and machine learning, beginner friendly yet industry powerful. Why Python? Simple and readable syntax, large community support, Python has it, that is open source, rich ecosystem of libraries like pandas, PyChart, these are the Seaborn and NumPy. These are the libraries widely used in data science and machine learning, beginners friendly yet industry powerful. Python is to data science what English is to literature. Python is to data science what English is to literature. Like English related to literature, so Python is related to data science as a beginner format. Therefore, we start writing code. Before we start writing code, we must understand the nature of the language we are using. Python is not just a language, it has certain characteristics that make it powerful for data science, with the most critical ones being: Python features description, scripting language. Python programs can run independently. You can write standalone scripts that execute without needing compilation beforehand. Dynamic language. You do not need to explicitly declare data types. The interpreter automatically understands the type based on the assigned value. High level language. Easy for humans to read and write. It abstracts away complex machine level details. Object oriented language. Everything in Python is treated as an object. You work with objects, their properties, and their methods. Modular language. You can extend Python's capabilities using modules and packages. This make it scalable and powerful. Interpreted language. Python executes code line by line, which makes debugging easier. Portable. Code written in Python can run across different operating systems with minimal changes. Wide uses. Use the data science Used in data science, web development, automation, game development, networking, and more. Important Python libraries for data science. Python becomes powerful because of its ecosystem, library, package, and purpose. NumPy, numerical computing and array operation. SciPy, scientific, scientific and mathematical computation. Pandas, data manipulation and structured data handling. Stats models. Stats models. Statistical modeling and hypothesis testing. Scikit-learn. Scikit-learn, machine learning and model building. TensorFlow and Keras, deep learning and AI model development. NLTK, natural language processing task. Matplotlib, Seaborn, data visualization. Why this matters? Without these libraries, Python would be a general programming language. With them, it becomes a great language for performing various data science tasks. The distribution Anaconda. Instead of installing everything separately, data scientists typically use a distribution called Anaconda. What is a distribution? A distribution is a bundled collection of Python, Jupyter Notebook, popular data science libraries, package management tools. It saves time and avoids compatibility issues. How to download Anaconda? Google download Anaconda. Use the link here. Download Anaconda, www.anaconda.com. Download success registered script. That is the link. And components inside Anaconda. Once installed, Anaconda gives us access to Python, Jupyter Notebook, Spider, package managers, that is Conda, and many pre-installed libraries. Think of Anaconda as a data science toolkit. 4 ways to open Jupyter Notebook. There are multiple ways, and 4 ways, that is are the ways, not a 4 ways. 3 ways. Using Anaconda Navigator, searching Jupyter Notebook from start menu, and using Anaconda prompt and typing. Jupyter Notebook. The fastest method is usually search directly Jupyter Notebook, but we use the third method especially when we work out of the custom directory. Why we prefer Jupyter Notebook? Jupyter allow us to write code, write explanation, add headings, insert images, debug interactively, see outputs immediately. It is ideal for learning, experimentation, data analysis. Understand Jupyter Notebook. What is Jupyter Notebook? Jupyter Notebook is an interactive computing environment where you can write code, execute code, write explanation, markdown, display outputs, add images, and visualization. It is widely used in data science, machine learning, research, and teaching. File types in Python. When working with Python, you may encounter .py Python script file. .ipynb stands for Interactive Python Notebook. that allows can be created using Jupyter Notebook. That is, in a way, it's a Jupyter Notebook file. .py file contains only code. .ipy and b file contains code, text explanation, outputs and visualizations. Structure of the Jupyter Notebook. A Jupyter Notebook is divided into cells. There are three main types of cells: code cell, markdown cell and raw cell. Code cell used to write and execute Python code. The output appears immediately below the cell. Execution happens line by line. And code is print hello, hello, namaste. Output hello, namaste. Markdown cell used to write headings, explanations, bullet points and tables, mathematical formulas. This is what makes Jupyter ideal for explanation, storing codes, sharing descriptive scripts and teachings. Raw cell rarely used in beginner session. It stores text that is not executed and not formatted. Raw cell, this is raw text cell. That is the example. Cell modes in Jupyter. Jupyter operates in two modes: edit mode and command mode. Edit mode. Edit mode, you can modify the contents of a cell, activated by pressing enter and green border appears. Command mode, used to perform notebook level operation, activated by pressing escape button and blue border appears. Then blue border appears. Used to perform notebook level operation, command mode, activate by pressing escape and blue border appears. Important shortcuts: action shortcut, run cell for running a cell, that is control plus enter. Run and add new cell, alter plus enter. Add cell above A in command mode, capital A, and add cell below, capital B in command mode. Delete cell D plus D. Convert to markdown, escape plus capital M, escape plus M. Convert to raw, escape plus capital R or escape plus R. Convert to code, escape plus Y or escape plus capital Y. List of complete shortcut, control plus shift plus capital H. Python syntax rule, case sensitivity. Python case sensitivity, this means value and value are different. Value, small value and capital value, capital V or small v, these are different. Data, small d and capital D, these are different. Data and data. Example: x, small x is equal to 10, capital X is equal to 20. Then output will be 10 and 20 after printing small x and capital X. Python treats them as two completely different variables. In indentation, unlike many other programming languages, Python doesn't use brackets to define blocks of codes, uses indentation. Indentation is not optional, it defines structures. That is, if 5 is greater than 2, indentation, then 4 spaces, print 5 is greater than 2, output 5 is greater than 2. If indentation is incorrect, Python throws an error. Indentation usually follows 4 spaces convention. Comments in Python. Comments are used to explain code. They are ignored during execution. Single line command. This is a single line command. Print hello, hello. Python does not have a traditional multi-line command symbol. We typically use multiple hash symbols or triple quotes for documentation style. Just like that, you can see here hash comment 1, hash dot 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 continued comment 1, hash dot 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 continued comment 1. That is triple quotes. This is a multi-line command, triple quotes, and single quote /n for the new line. This is a then /n for the new line, multi-line /n for the new line, comment /n for the new line. This is a multi-line comment also. Variables, identifiers and keywords. What is a variable? A variable is a name that refers to an object stored in memory. It is not the value itself, it is a reference to the value. Like age is equal to 25, age variable or identifier, 25 is object value stored in memory. Variable versus identifier versus keyword, term and meaning. Identifier, the name given to a variable. Variable, a name referred or a reference to an object. Keyword, reserved word in Python cannot be used as a variable name. Example, if, else, for, while, true, false, none. These are the keywords. This distinction is subtle but important. Identifier, an identifier is simply a name. It is the label we give to something in Python. Examples, variables names, function names, class names, modules names. Like code, age is equal to 25. Here age is an identifier, it's just a name. Variable, a variable is an identifier that is currently pointing to an object in a memory. In a simple word, identifier plus assigned value is equal to variable. Age is equal to 25. Now age is a identifier, 25 is an object in memory. Age referring to 25 variable. If we remove the assignment, age and 25 like this, now age is just a name. It becomes a variable only when it refers a value. Keyword, a keyword is a reserved word in Python. These words already have a predefined meaning in the language. You cannot use them as identifiers. Example, if, else, for, while, true, false, none. If is equal to 10, this will cause an error. Cell in 25 line 1. If is equal to 10, this will cause an error. Syntax error or invalid syntax. Real difference. Think of it like this: identifier, a name tag; variable, a name tag attached to a box; object, the content inside the box. If there is no box attached, it is just a name. If the name is reserved by the system, it is a keyword. The technical difference: when you write Python, age is equal to 25, then Python first creates an object 25 in the memory, creates the name age, binds the name to the object. The binding makes it a variable. Naming rules, INC rules: variable name cannot start with a number, cannot contain spaces, cannot contain special characters except hyphen, except underscore, and cannot be Python keyword. Code, valid, total marks is equal to 95, invalid, to value is equal to 10, starts with number, total marks, total space marks is equal to 50, contains space, if is equal to 20, keyword. Error, trace back, to value is equal to 10, starts with number, syntax error, invalid, decimal, literal. Naming conventions, best practices. Converted from Jupyter Notebook. Although Python allows flexibility, good practice suggests use lowercase, use underscore to separate words, avoid starting or ending with underscore unnecessarily. Good, student score, avoid student score, student like this, value like this. Namespace concept. All variables exist inside a namespace. You can see available names using dir, in, out, text, 10, 12, 9, bulletin, bulletins, doc, loader, name, package, session, specs, DH, IL0, IL1, 2, 3, 4, 5, or I1, I10, 11, 12, 13, 14, 15. You can say that I2, I3, I4, I5, I6, I9, IH, II, triple I, underscore triple I or underscore OH, age, exit, get, underscore IPython, open, quit, X. Objects remain in the namespace until the session ends. They are deleted using DEL. DEL X means the object X will not be in the namespace anymore. DIR in out X, capital X, underscore 10, 12, 15, 9, underscore double underscore triple underscore bulletin with underscores, bulletins, docs, loader, name, package, session, specs, DH, I, and like before. Thank you very much.